this is my Medium. This is my Medium account. As you can see, my profile here, and so today we'll be looking at my article 264, which is about depth first search in Java, solutions to everyday challenges. Today we would look at the first problem, which is finding the path in maze. So basically DFS is a fundamental algorithm. It's used for traversing or searching tree or graph data structures. And here in the first problem, finding the maze, let's just talk about the code. Let me give an overview of the code. It has the main method, which would be the entry point of the program. It defines a 4x4 matrix as a 2D array. Here 1 represents a passable cell and 0 represents the blocked cell, and an instance of maze solver is created, and we are calling the solve maze method. And so we are calling the solve maze method, and maze is given as an argument, and depending on whether the path is found, it prints path found, and if there's no path found, it prints no path found. And then we have solve maze method. It's basically this method initializes the visited array, and which keeps track of the cells that have already been visited during the DFS, and it then starts the DFS from the top left corner of the maze, which is 0 0. If a path is found, it returns true, otherwise it returns false. And then we have the constants here. We have row moves, call moves. These are the constants. These array represent the possible movements in the maze. The row moves array defines vertical movements up and down, and the call moves array defines horizontal movements, which is left and right. And n is a constant that represents the size of the maze. In this case, it is set to 4. Because the maze is a 4x4 grid here. And then we have the isSafe method. This method basically checks if a cell x comma y is a valid move. If it checks if x is between 0 and n and y is between 0 and n, and ensures that the cell is within the bounds of the maze, and ensures that the cell is passable by checking the value at the cell. If it is 1, it is passable, and if it is 0, it is blocked. And also ensures the cell hasn't been visited before. It checks the visited array and ensures the cell hasn't been visited before. And if all these conditions are met, the method returns true, indicating that the cell is safe to visit. Then we have this DFS method. Here the base case, we have a base case which checks if n is if x and y, or if the algorithm reaches the bottom right corner, then it returns true. That means it would indicate a path has been found. Here in this case, if x is 3 and y is equal to 3, then it would return true, which means it reaches the bottom right corner and the path has been found. And then we have the isSafe method, and here this is a recursive case. The algorithm checks if the current cell is safe to visit using isSafe. and if it is safe, it marks the cell as visited by setting the visited array visitor of xy as true, and the particular cell at the visited array as true, and then it tries to move to the neighboring cells up, down, left, right using the row moves and call move arrays. It recursively calls DFS for each neighboring cell. If any of the recursive calls returns true, it indicates that a path has been found, so the method returns true. If no path is found from the current cell, the algorithm backtracks by unmarking the cell at the visited array as false and continues searching. And here we can see that the row moves and call moves and n not private, static, final. Private is to limit the access to within the class, and static ensures there's only one shared copy of the array for all instances of the class. Final ensures that the references to the array cannot be changed after initialization, keeping the movement logic constant. And yeah, so if the DFS has previously visited other cells, it would have originated from one of those cells. So when the current cell is found unsafe, DFS backtracks to the previous cell and continues to explore other directions from there. And if a DFS had other directions to explore from the previous cell, it would move to those unvisited and safe cells. Let me explain it with an example that's given here. Let's take the example that's given here in the main method. So here I have put this input here, and I have represented it in this grid, 4x4 grid, and here is the input, and here I add for every cell I put the xy coordinates and also the value at that particular cell. Here we need to remember that 1 is passable and 0 is blocked, and the boolean array, basically when the boolean array is initialized, it has all false values because that's a default boolean defaults to false, so every value in this array would be false. But as I go through the walk through the code, I've changed it to true, and I've highlighted them and with green color. And here, so let's go into the algorithm. First we are going with x we are starting right here. X is equal to 0 and y is equal to 0 and the value is 1. So is the base case, no, it returns false. It is not 3, it is not in the it is not x is not 3 and y is not 3, so it returns false. And we are checking if it is safe. Yes, this is within bounds and the value is passable, and the visited is false, so the value at the visited would be false. So yes, this is safe. So we are starting as it is given here. We are starting with the for loop here, and as you can see, I is equal to 0, and the new row would be calculated with x, and the first value of the row moves array which would be -1, and the same with new call, then y is 0, and the first value of the call moves array which is 0, and then we are starting the DFS. We are calling the DFS, and here is it safe? No, it is not. It is not a base case. No. Is it safe? No, because it's out of bounds because of the -1 there, and so DFS returns false. So then we are incrementing the I is equal to 1 here. So we are doing the same thing with I is equal to, with the next increment of I, the x and y would be 0 0, and we are taking the second values from the row move and the call move arrays, and we are calling the DFS, and this is not a base case and it is not safe because it is blocked. As we see here, at 1 and 0 the value is 0, and so DFS returns false again. So what happens when DFS returns false? It goes and increments the I, it goes to the next value of the I. So here I is equal to 2, and again we are doing the same thing and calling the DFS again. This is not safe. Why? Because it's out of bounds because of the -1 here. So again DFS is returning false, and again so we are in the for loop now. We are incrementing it. I is equal to 3. We are doing the same thing, calculating new row, new call, and calling the DFS. This is not a base case, no, and it is safe. Yes, it is safe. So we are visiting 0 and 1 as visited. As I say, I've already done that. So the 0 and 1 would be this one right here. So I've already marked it as true. And then so first we were here and now we have come here. So let me just to show the, let me highlight it with yellow to show the difference, to show where we are now. So we are here right now, and so what happens now? We just marked it as visited. So what would happen now? Because it is safe and we marked it. So now let's look at the code. What happens? What happens after we marked it as visited? We have to go into the for loop now. Yeah, we have to start the for loop. So here we are starting the for loop, and the values are 0 and 1, x and y are 0 and 1, and we have already marked them as visited. No, it's not a base case. We have already looked all that, but I'm just repeating the same thing here. Just copying this. Is it safe? Yes, I'm putting it here. And now we are starting the for loop. So I is equal to 0, and again we are doing the same thing, calculating new row and new call, calling the DFS, and again this is not safe because it's out of bounds and DFS returns false. So what would we do? We would increment the next value of I, and here again we are calculating the new row and new call and calling the DFS, and it is safe here. And so we are marking it as visited. So we are marking 1 and 1 as visited. So let me see, where is 1 and 1? Yes, here, it's right here, and we have marked it as visited. So let me highlight here. I could again initialize everything to false and change it again, but I'm thinking I would just keep it this way this time, and just maybe highlight it with yellow to show the difference. And then we have so right now we are at 1 and 1. So I'm taking this 1 and 1 and putting it here, and again we are starting the for loop and calculating the new row and new call and calling the DFS. Again it is not safe because we have already visited it, and let's check if we are already 0 and 1. Have we visited it already? Yep, Yeah, we have already researched. So this is not safe, so DFS returns false. And again we are incrementing I, and here this time we are having 2 comma 1 and it is blocked, so it is not safe. Let's look at the value at 2 comma 1. 2 comma 2 and 1, it's, yeah, the value is 0, so it's blocked, so it is not safe. And and then the next one would be, again we are incrementing I, and I is 2 now, and now the new row and new call would be 1 comma 0, which is not safe. Again it is blocked, so because the value there is 0 and DFS returns false. And again we are incrementing I would be 3 now, and calculating new row and new call and calling the DFS with 1 comma 2. Is it safe? Yes, it is within the bounds. And let's check 1 comma 2, which would be 1 comma 2, which would, the value is 1, and it is not visited, so let's mark it as visited. And then so now we are starting the for loop again, and again we are repeating from I is equal to 0 to 3. And when we have I is equal to 3, we are calling the DFS with 1 comma 3, and here it is safe. So what happens in the algorithm when it is safe? If safe visited, it would mark the visited as true and start the going to the for loop. So we will do the same, 1 comma 3. So we'll be here right now, here we would be right here. And so what happens there after that? So here 1 comma 3, so again we are starting the for loop, and when we calculate the new row and new column and calling the DFS with 0 comma 3, we again have let's check it, we find that it is safe to visit. Let's go and check the 0 comma 3. Yeah, this is 0 comma 3, this one. I'll highlight it as yellow. As you can see here, we have to mark it as true here. Okay, let me temporarily mark it as true, but later we would unmark it as visited, and later we need to change it to false again. So let's, for the time being, let's mark it as true. And so here we are again iterating, going into the for loop. When I is equal to 0, again it returns false, and I is equal to 1, 2, 3, everything returns false. So when we are here, when we went through the for loop and it returns false, so now there is no other way to go. So it's the end of the for loop, so we have no other way but to, as you can see here, when we come out of the for loop, and the DFS haven't written true, we have to make mark it as false. So that's what I've done here. So DFS returns false, so I'm marking 0,3 as unvisited. So let me go and do that as it was previously, and I'm just going to take out the highlight just to avoid some confusion. So right now we are right here and we have marked it as unvisited, and what are we gonna do next? So now, and now we have to go back to the previous loop, which would be 1,3. So we would be right here, and the I would be 1, the value of I would be 1, so I've written put it here. And again we are finding the new row and new call and calling the DFS with value 2,3, and it is safe. So we are starting the for loop, we are marking it as visited. Let's go and take a look at through 2,3. Yes, 2,3, it's right here, and we are marking it as visited. Let's mark it as visited, and as we can see the value here is 1, that means it's passable. And let's take a look at that. So again we are starting the for loop with the values 2,3, x is 2 and y is 3, and again we are starting the for loop, and with I is equal to 0, it's returning, the DFS is returning false. But with I is equal to 1, we are having the calling the DFS with 3 and 3. So what happens? Is this a base case? Yes, it is, because n is 4 and n minus 1 is 3. Yes, this is the base case that we were looking for. And so just a second. Yes, and what does it mean if the base case returns true? It means that the algorithm has reached the bottom right corner, and the DFS is gonna return true. And so here we would be, so the solve maze method would return true, and if it returns true, it's gonna print out path found. Yes, and the time complexity for this algorithm is O n of n square, and because each cell is visited once, and this is a space complexity due to the recursion stack and the visited array. Okay, and so I think so I would like to end this video right here.